Thank you all for joining this Free Friday seminar. Once again, I want to thank Davis-Thompson Foundation, Ariel, Rafa, and in this occasion, we have our friend, Dr. Melissa Macias Rioseco. So, a few words about her. Melissa is a diagnostic pathologist and an associate professor of clinical diagnostic pathology at the California Animal Health and Food Safety Laboratory System and the Department of Pathology, Microbiology, and Immunology at University of California, Davis. She earned her DVM in University Autónoma of Baja California, Mexicali, Mexico. She pursued a master in preventive veterinary medicine at the University of California, then 2 years of residency training in anatomic pathology at Washington State University, and a PhD from the Universidad de la República and Instituto Nacional de Investigación Agropecuaria en Montevideo, Uruguay. And finally, she achieved her diplomate status at the anatomic pathology by the CBP in 2022. Her professional interests include pathology of livestock, commercial poultry, epidemiology, has a specific focus on abortion pathology in production animals, primary bovine, and reproductive pathology. So, she will share with us her knowledge. She told me that she prefers to have questions during the presentation, and actually she might do some questions. So yeah, feel free to write in the chat. I can read the messages during the presentation, if that's okay with you, Melissa, right?
Absolutely. Thank you, Robert. Good morning,
Okay.
everyone. Well, good
All
morning
yours.
for me. What is it? Midday for the rest of the people, Central Time. And then we go to South America. It's also almost noon, I think. Okay, so thank you for the introduction, Robert. The first thing is that I tend to get excited and then I talk too quickly. So I'm gonna try to pace myself. But if there's something that she's like, oh, this girl went super fast, please put something on the chat and then Robert is gonna let me know or Ariel is gonna let me know so I can slow down and go back to reality. Okay, with that being said, let's do this. Sharing screen. Put here. I click here and then I say, no, I don't want that. And then I flip. Okay. All right. Today's subject or name of the presentation, we're going to focus on placenta. And when I was talking with Robert, Dr. Olivares, he mentioned, he actually went straight and said, like, hey, what about placenta? Because I really like abortion, especially in bovines, but in reproductive and livestock species, like he mentioned before. However, I think placenta is one of those organs that when we get it on the necropsy floor, we don't know what to do. We either overcomplicate it or we think everything is a lesion and we're not sure what is actually a lesion. And it happens to all of us. And also when we get it, it's sometimes or most of the times autolyzed or rotten, so we don't know how significant. I remember when I was working with my team and friends in Uruguay, one of my colleagues mentioned like, "Whoa, it's gonna be rotten. It's gonna be E. coli everything. Like it's gonna be full of E. coli. So what are you gonna isolate?" I'm like, "Yeah, that's actually a good point." However, we want to feel comfortable and see what does it mean when you isolate E. coli, and if you have not had lesions. So for today's presentation, we have a few learning objectives. I'm going to try to help everyone to understand what a normal placenta anatomy is. That means recognize the common, either gross placenta findings, correlate placenta lesions with fetal diseases abortion. That means connecting the dots. We're pathologists / diagnosticians, so we have to have a full picture and then take a conclusion for that. So put points between the lesions and then what does it mean in the fetus and what does it mean in the abortion case. And then also improve sampling and submission practices because we do our best. And like I said, when we get the placenta, if it's especially coming from bovines, if it's a dairy, well, you're lucky because you can pick it up at the moment of milking. But if it's a beef, by the time you find the placenta, you probably get affected or you have a fox or a coyote eating it. So you have to double check whether you actually pick the best of it. All right, before I want to share some learning tools because I think this is really important and I want to put it before instead of at the end because I don't want to forget. So this person over here and this lady over here, the person on the left is Dr. Kurt Bernschke and the person on the right, the lady in the center of two people, is Dr. Shirley Driscoll. So both of them are MDs, were MDs, rest in peace, passed away 2018, I think, or 22. And interestingly, they were MDs, they were human doctors, they were pathologists, fellows, but they were one of the two first people that got interested in placenta. And together they brought the Bible of placenta pathology. It's human, however, a lot of we know in humans is because we keep observing our non-human primates and rodents. So this is on the 7th edition. You can find the full edition online for free. So take note from that one. It has beautiful pictures. It has really interesting description of processes, the processes that were very well described in humans, unlike in animals. So it will give us an idea of what is, how to approach it and sample and everything. So Dr. Shirley Driscoll, she practiced in the East Coast and she passed away in 2018, I think. Dr. Kurt Bernishkel, he based in San Diego, actually. So he was an MD, he moved it, and he was working for UCSD, the University of California, San Diego. Then, because he really liked placenta and he was a comparative pathologist, more or less, he was a human pathologist, but he used a lot of cases for animals. So he was also part of the board of the San Diego Zoo. So he was part of the people that organized San Diego Zoo. And he's one of the first people that created the zoo frozen collection. Have you heard of it? It's a frozen piece of cells and embryos that it was being created throughout the years for endangered species. So he had this specific collection of comparative placentation. It's a website. Again, you can get access to both of them online. But this website on the left is huge because, again, I want to make the emphasis that I'm dealing with a human pathologist, and he went ahead with a lot of collaborators by being really closely involved with the San Diego Zoo and create a whole collection of placentas specimens for different species. So this is great if you're dealing with compacting placenta, because only the placenta by itself can be super odd. But imagine when you have a placenta for a sea lion or a placenta for a whale, and like, well, I don't know, what is the F? I like the shape of it. Like, does it have an F? Where does it start? Does it have a star? So all this comparative placentation, it's key. So use this tool. It's free and it's super easy to access this. Then another website that I frequently use for teaching is this VisGuard, which is coming from the University of Florida. It's a whole guide with pictures. It's actually created for Dr. Dort. So it has really good pictures. Pictures are kind of old, but the good pictures are the classics. So throughout the presentation, you're going to see pictures that either were taken for these two websites or other websites. And I did my best to put the reference on the bottom. However, I just want to make sure that sometimes people get missed, so everything should be referenced there. So, okay, so you have three websites. You have a book for free online, and then you also have a comparative presentation, and then you have a bovine reproduction guide that has everything. So highly recommend it. All right, so first things first. Our name of the presentation is called Placenta, Common Lesions and Findings. So this is a frequent question that I run into my students when they say, like, what is a lesion and what is a finding? Because when you're looking at the organ, you want to be sure that if this is abnormal or this is normal, oh, it's a lesion. So in pathology, specifically anatomic pathology, the specific things, and I want to make emphasis that also applies with epidemiology. It's everything about pattern. Pattern recognition is going to be your way to go. So pattern recognition is the key to the process of diagnosis. If you are able to see what pattern or what distribution your lesion has or your finding, we're going to talk on it in a second, you can actually nail the morphological diagnosis in a pretty high percentage. Meaning, similarly in epidemiology, remember I have a background in epi. If you identify who's affected and who's not, that's the first pattern that you can see. That's going to give you a hint of who's exposed to or who is actually affected by the risk factor. So pattern recognition is the key that you're going to have to train yourself as a pathologist / diagnostician in order to feel comfortable enough to see what are you going for and then what are you going to rule out. More specifically, what is a lesion and what is a finding? A lesion is what we see. Like, I open the animal, I open the fetus, I got the placenta, and it's anything that I'm looking at, but it has to be an abnormal change. It has to be abnormal. A finding is what you know about it. So it's any observation, like you can open and say, like, oh, it has organic material added to the covering the cotyledon. That's a finding. Any specific observation, characteristic, or any data that you actually recording, that's your finding. So because lesion is what we see, And then findings can be many type of findings. Findings can be normal findings. Lesions are never going to be a normal lesion. Okay, and I'm gonna pause because it's a big deal. A finding can be incidental, like, oh, I just happened to run into things that is not related to the cause of death, but it's a finding because I'm observing it. It could be pathological, which that's abnormal, and then that could turn into a lesion. It could be artifactual, like when you euthanize an animal and then you suddenly have a huge and enlarged spleen. That's an artifactual enlargement. So that's a finding, and it's artifactual. It's coming from an artifact. And then you also have postmortem changes, like, oh, is this actually real? Like the hypostatic congestion when the animal dies on one side, and then the blood gets pulled by the gravity. So that's a postmortem change. So you have to keep in mind what is that? What is that? What's the limit? So a finding is just something that you can see with your eye and you can actually see with a microscope, or you see as a result, like as a report, like, oh, the finding is this is PCR detected or not detected. But that's actually imply a disease. It's just finding is the first step. More specifically, all the lesions are interpreted as findings. So, like I mentioned, necrotizing placentitis could be it's actually a lesion because it's abnormal. A type of inflammation is suppurative placentitis, chronic edema, chorionic edema, cotyledonary infarction. So any lesion is actually also a finding. So once you have your lesion, you should describe your lesion using the proper terminology, meaning created a morphological diagnosis. And that's what everyone tried to standardize, and that's what we all as pathologists got to get together and said, okay, I have a lesion. How do I tell you that's the lesion? Well, you're gonna organize information by process, what is actually happening, the modifier of the process, if it's a type of inflammation, what type of inflammation is, what distribution it has, if it's only one area, the front and the bottom, cranioventral, if it's everywhere, if it's only over there, multifocal. This is hard for me because I think everything is severe, but we have to keep in mind that you also consider the percentage of the organ that is affected. And if you can tell the duration, if it's chronic, if you have fibrosis, or if it's acute, if you have fibrin. So for that, you will have, for example, placentitis, necrotizing, suppurative, because you can have two modifiers sometimes playing. And then what's the distribution, if it's severe or not. Okay? All right, so you first start observing your cartographs, observing your case, and then when you observe it, you identify a finding. Like I said, it could be normal, it could be artifactual, it could be postmortem, and then you're gonna interpret that finding. The step that I said, oh, this is actually normal, this is actually an artifact, this is actually a postmortem, and when you interpret your finding, you're gonna then conclude your lesion. See? So you observe first, and then, for example, you see white plaques in the intercutaneous membrane. What does that mean? I'm gonna tell you then what is a white plaques in the intercutaneous membrane. Where you can also have cases that you have enlarged or like really meaty cod lesions. What does it mean? So you're just observing, you just register the information, and you register the findings, and then eventually you're gonna interpret it and say, like, my morphologic diagnosis is inflammation. It's gonna be a necrotizing type of inflammation, and it's gonna have a distribution of multifocal to coalescent severe. So those are like the organization how I want you to think through when you're talking about lesions and findings, specifically because you're gonna have a lot of findings that not gonna mean a lot. They're not gonna mean a lot, and a lot of findings that they look abnormal. So like, this is definitely something weird. Yeah, it could be weird, but it could be also artifactual. So you have to have your knowledge in order to interpret the lesion and then turn into a lesion. Okay. So a finding, because I like repetition, and this is how people learn. A finding is what you see. You see that, you observe it. And a lesion is what it means pathologically. That's the main distinction. So you get what you see, you're looking at the finding in the placenta, and then the lesion is actually what it means that pathologically speaking to the case. All right? Then second, well, we're here because we want to talk about placenta. And what makes placenta interesting is that it's a mammals. We do have different type of mammals. We have, for example, the metatheria, which are marsupials. This is a picture from my backyard. I'm really proud of it. Actually, I didn't take the picture. My husband did. But we call her Eugenia. She's been living in our backyard for the last year and a half. And we see her. Our dogs hate her because they keep barking at her. But I just want to make sure that this is one of the few marsupials in North America. So we don't have that many in this part of the world. The one on the right is a picture that represents what eutherias, which the composition of the word eu means real. So it's like what they call like the real mammalians, right? Like they have a placentation and they actually diverge for a specific part of the Jurassic, upper Jurassic period. So mammalians both, different type of mammalians. But today we're gonna just focus on eutherians, meaning placenta, real ones. But yeah, so just keep in mind that your mind is open and then what does it mean for the population that you're working on. All right, so placenta is a super cool organ. And there's not much information. Like I showed in the book that it was first created about human placenta was back in the 40s. No, never mind, back in the 60s. So it's still areas of, there's gaps in that area for information. But more specifically, I want you to keep in mind that it regulates the physiological exchange between the fetus and the mom. Is one of the many things this placenta does. Placenta doesn't care about the mom without some reason. It just cares about maintaining the fetus, the conceptus of the embryo healthy and being able to keep the whole pregnancy. So it's gonna do that in spite of a lot of things that the body of the mom or the dad wants to do. It wants to get rid of it, it wants to attack it, it wants to recognize it. So for that, it has to maintain different things. First, maintain the pregnancy. So it is an endocrine organ. More specifically, the specific points of the pregnancy or days of gestation that actually would trigger the release of progesterone and estrogens. Progesterone to maintain specifically the pregnancy. So it has potential to become or be treated as endocrine organ. It also promotes the selective transport of nutrients because the way the placentation goes, and we're going to talk about it, how different placenta is, how the placenta is in general between different species, depending on the number of cells and depending on how they contact. But it's actually going to have a different selective transport of nutrients, specifically gas transport, nutrients between the mom and the fetus, or more specifically the fetus, and of course antibodies. Like that's something that we work daily with. And like I mentioned before, it has two particularities or two key things, and it will be divided in two different ways. One is going to be divided the macroscopic shape, like how you look at like with your naked eye, the shape of the placenta, and how is the distribution of contact between the sites of contact of the fetus/mom between those two. So there will be naked eye, how it contacts between the two entities, the mom and the fetus. And then another one is microscopically the number of cell layers between the fetus and the mom. And this is just about the vascular system. So that's going to put us in terms of what's the communication between antibodies and antibodies, more specifically between the two groups. All right. If we talk about classification according the forms or points of contact, the first one, I think the first one that we feel more comfortable, it will be diffuse. And it's exactly what its name says. And the next one will be sonary. And again, exactly what it says. Diffuse will be multiple points of contact throughout the entire portion of the placenta. And this is seen in species as pigs and horses. Sonary, on the other hand, is actually observing carnivores. So it's like a tiny band. So literally what it says in the name is not so much so complicated. The next one will be discoid or cotyledonary. So the discoid exactly has a specific chunk of disc associated to it, and is usually seen in non-human primates and humans. And cotyledonary, which is the ones that we're going to talk the most today, because it's my personal experience, would be you have specific sites throughout the organ, and these sites are called cotyledons. All right, this is an image that I generated with AI, and I don't know why I keep doing this. I keep giving faith. I mean, I'm pretty sure I'm doing the wrong tool. So I put my reference and I put my notes, and then I put it like, hey, make a fancy drawing. And sometimes it works, sometimes it doesn't. So I put below A generated. But this one, I think is actually represented to what I'm trying to say. So we go tape by tape. This is a classification in terms of the number of cells between the fetal and the maternal blood. So this is microscopically. This is not an naked eye. This is microscopically doing the microscope. All right. Each column is going to be a different type of placenta. From left to right, you have 6 layers, 5 layers, 4 layers, 3 layers, 1 layer. And then the layers between the fetus and the mom are going to be described in the third row. And this is important. I'm not going to jump straight to here because I wanted to be sure that you can see how exactly the 6 layers on the 6th column, 5, 4, 3, 1. And it's mainly defined by either is maternal endothelium and maternal connective tissue. Then you have maternal epithelium. And then you have fetal epithelium, and then you have connective tissue, and at the end, fetal endothelium. And then you're gonna be removing one in the next phase or the next type, that's synaptochorial. You don't have maternal endothelium. If you can see, it's gone. So the cells in the bottom is the blood of the mom. This red blood cells, red blood cells, red blood cells. Then it's followed by the cubicles, like type of cubes, like square cells. Those are the tissue maternal cells. So you can see how there's actually very rarely present, actually not present in the last one. And then the next one will be fetal or the chorionic, which we're going to define, which is the chorion tissues. So that would be like the type of square ones. And then you have a combination between the chorionic and the blood, fetal blood. So those are the tiny mistakes that I tell you about AI sometimes does. But just keep me mindful of the limitations what you have. And then it gives you an example, like the thickest one, like I said, from left to right is 6, 5, 4, 3, 1. So the thickest is going to be the one that has 6, of course, and that's present in horses and pigs. The next one is going to be the synaptochorial, which is in ruminants, which is what we're going to focus today, most of it. And then you have epitheliochorial, carnivores, you have primates, us and non-human primates, and then you have hemochorial, which is the rodents, which is mouse, rats, rabbit, and agomorphs, rabbits, and then some bats. So this on the bottom is simple. It makes sense, right? So the efficiency of exchange. If you have a really thick 6 layers type of placenta, then you're going to have a low efficiency of exchange in anything around. If you have a 1 layer thickness placenta, then you're going to have a very high efficiency exchange. So they find efficiency because that means that what goes one way goes the other way. So that's why you have to that's about the transport and how it goes between them. All right. So this is just a representation of the classification of the placenta depending on the microscopic view, not with the naked eye, but in terms of how thick it is between the fetal and maternal blood contact. All right. So more specifically, we said ruminants. We're going to deal with the cotyledonary placenta. So it has different sides, right? It has like one there, one there, one there. And then more specifically, in terms of how it looks microscopically, it's going to be synaptochorial placenta. And then because it has cotyledons, it's going to have placentomes, and I'm going to show you how they look like. And then evidently, it's also going to have the intercotyledonary membranes or spaces. All right, so we talk about classification according to the points of contact, and these 2 pictures are taken from the Colorado State websites. And this is a really old, cute picture, and I really like it because it's so tiny, and when it's tiny, at least for me, it's easy to see who is what. When it gets big, everything is so messy. So let's go with the simples. So we have the caruncles, which are based on the endometrium, which is part of the mom, caruncles. There's a mnemonic in English that is called that the mom drives the car, and therefore is the caruncles. That's how people remember. That's how I remember. Then the caruncles are gonna have contact specifically with the cotyledon, which is a portion of the placenta. And together they're gonna form the placentome, which sounds like a fancy name for a superhero. Then you're gonna have, in this particular case, you can see how's the uterine wall, because you have a connection of both. So the cupping, and then both the structures are together. And you can see the placentome, they look like ventosas. If you're an octopus, like the structures that octopus have throughout, and each portion of it. And then you have the fetus or the embryo in this particular case. You have fluid. So there's a lot of fluid here. Who is what? I can tell you that the amnion is the fluid that has more contact with the fetus. Let's take about that. First information that. The caruncles are formed. They're like the endometrium comes with caruncles, but they're kind of activated by specific markers, genetic, like OX10, 11, and what W and T signaling, which I don't know what W and T signaling is specifically, homebox genes. So it's marked by, hey, you're there. And they're present since you're born as a female with a uterus, but they're gonna be dependent activated in pregnancy more specifically. So they do have a thick stroma, they have fibroblasts because they're really strong, they have to maintain everything, blood vessels, and they normally lack specific glands because there's no point of contact. I mean, there's a point of contact, but just to keep in mind that the regulation is done, the regulation is done by genes, but however, they're present. Like you see them activated once it's pregnant though. Okay, so this is another picture taken from the collection that I showed before, and this is a twin pregnancy in bovine, which is tricky because we do know that when you have twin pregnancies in bovines, you have the risk of freemartinism. All right, so if you take notice, there's blue bags 2 blue bags, and then 1 yellow bag. The blue bag is artificial. They actually inject stained methylene blue to make it like marker that this is 1 bag. So the purpose of this picture is because that way you can see 1 bag has specific fluid, and then the other bags have specific fluid, the yellow one. So the amniotic sac is the most outside layer bag. And that holds a specific type of fluid, which is the amniotic fluid. And they're sharing the chorioallantoid circulation, which the amniotic fluid is actually formed by salivary. It's kind of like glary, viscous, and it's mainly composed of the fetal salivary secretion, if you think. It's actually controlled by the fetal swallowing, the amount of it. And the allantoic fluid, which is the yellow fluid in this picture over here. So you have division of this portion and the yellow fluid. It's actually watery and it's derived by the fetal kidney and urachus. So it's regulated. The amount of fluid between those two sacs, let's call it that, the yellow ones and the blue ones, is actually made by the permeability of the membranes. So what I'm pointing out, the yellow, it will be the chorion or the outer enclosure. Outer enclosure, chorioallantoids, or at the chorioallantoid cavity. So this is one presentation of that. This is another one that we can see. So in this picture, we have the uterus open, and we can see 1 bag and then 2 bags. So the uterus is all this. Let me place a point. The uterus is all this. Wrap it. And then this interface between is a higher picture here, and you can see the carbuncle on the portion of the uterus connected with the cotyledon, which is outside, therefore, the chorion, and together they're going to make the placentum. So the number of cotyledons change. They can vary between 70 and 120. And things to identify here is, at this point, I just wanted to identify normal. No, I just wanted to go anatomy. So you have 1 cotyledon here, 1 cotyledon here, 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 here. They look like pepperonis, if you ask me. The cotyledons on that part specifically are filling the uterine horns, and they're going to be super large. And the placenta membranes are actually in the whole entire horn. The cotyledons are closer tip of the uterine. I wanted to keep from this particular picture just that. Just focus on the placentum, the union between these two. And microscopically, this will look something like this. This is actually taken from BSPO. And this particular cotyledon, I should say, placentum, is actually from a goat, but it's a ruminant. So you can observe the portion of endometrium. And then, this firmly attached, the carbuncle. So this would be the cotyledon portion of it. And all these structures over here are called the labyrinth. Again, this is actually the fetus from this picture when I took it out. So identify the structures. This is my cotyledon, 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 cotyledon. So the chorion is going to be, like I said, the most outside, the outermost enclosure, the outside back of it. And I hope you can see that there's a distinction between there's a bag inside a bag effect. And that's key. A bag or a sac inside another sac. So you have this edge here, and then you have this edge here. You don't believe me? Boom. So trying like to see a bag inside a bag. I'm going back. You see the edge and the difference in between dimensions. This looks meaty and this looks flat. So that is the amniotic cavity that is inside the chorion, and that actually surrounds the specific embryo. In this particular picture, I removed the chorion and I've opened the amniotic cavity. So you still have portion. You can see the cotyledons because I only opened one edge. And this is full. You see how it's folded? And you can see the fetus by itself. All right, so for memory and anatomy, the chorion is going to be the outside most layer enclosing all the membranes. The allantois is another sac that is actually coming from the back of the back legs, let's call it, and actually attaches to the umbilical cord. And that's all going to be filled with space between the chorion and the amnion. So it's like allantoid cavities, which would be the space between here, that's not here. And then the amnion is the innermost membrane. It's the sac inside a sac. So I did something. I created a placenta with a Ziploc bag. This is so fun. So I hope you can see my Legos marked outside this huge bag. Each Lego is going to be my cod litter. So this should be by itself the corium. So it's empty. This is why they send me to the necropsy. They just are like, I got your placenta, and it's full of cod litters because it's a rumen. And inside the corium, which is the outside bag, because inside that I have contact with the uterus, I'm gonna have specific type of fluid, and I'm gonna represent it as blue Legos. And this fluid is gonna be the allantoid fluid that is going to protect another bag, which is gonna be my amnion. But inside my amnion, I have, well, amniotic fluid. It's gonna be my blue legs. And my headless cow. So I have the fetus inside the amnion with the amniotic fluid. Done. And then I'm gonna grab the amnion and I put it into the allantoid fluid inside the corium bag. So it's a bag inside a bag effect. And the purpose of that is because that way the fetus is actually protected by specific waves. Like if you hit or something like that, the fetus is protected by the fluids. So you have multiple fluids. You have the allantoic fluid, you have the amniotic fluid. And it's important to remember because you want to keep track of who is wrapping who and who's having contact with who. And lastly, but not least, we have a uterus. This is the same uterus that it was outside. So what you saw before was the outside. This is the inside. This is like when you have a sock, a calcetin, and you put it inside out. You have your caruncles distributed throughout the horns. This is one horn. This is one horn. It's kind of like a donut. And there's specific organs, hormones that go through it that are going to prepare the endometrium to actually go with the conceptors, like, of course, prostaglandins and, of course, interferon T. But the purpose of this is just to keep in mind and say, like, okay, you need to increase vascularity, you increase extracellular matrix, specific things that wants to be required to prepare the uterus for this. All right. Robert, do you have any questions in the chat? Or Ariel?
Hi, Melissa. No questions so far.
Okay. All right, thank you. So we're going to the normal gross findings. Normal gross findings. So things that we have to keep in mind, and variation in cotyledon size. You do want to elaborate and take a look of how big the cotyledons are. Sometimes they're way, way too big. Sometimes they're too small, and that would mean something. If you have mineralization, frequently I get to the question like, I have mineralized placenta, and I don't know what it means. So it depends on the term. Pigmentation is a thing, especially in breeds that have pigment that are black. You're also going to have myelodema, and there's a really good article they're going to discuss later that tells about what does it mean for the myelodema specifically, in what terms, and how much is too much. And then the normal umbilical cord features, the torsion or not torsion. So why the placenta is important is because most of the times it offers informative tissue about abortion investigations. We don't get that often because, like I said, it's kind of hard to actually get access to the placenta when you're in the middle of the field. However, in cases when placenta is submitted, the diagnosis is actually, there's a statistical difference between submission of the diagnosis, reaching of the diagnosis, and now when they submit a placenta. It also gonna give you a hint of the maternal and fetal infectious process interface. Sometimes you don't have any lesions in the fetus, but you do have significant severe lesions in the placenta. And the pathogen is detected when the infectious is detected actually at the level of the placenta. So you might want to double check the bias you're introducing. It can also contain lesions when the fetus is super autolyzed, so the placenta can be preserved for a longer time. And then if you sometimes cannot reach the etiology diagnosis can give you. When we examine the placenta, I would say evidently how big it is, the weight, the color, how thick it is, the cotyledons, the size, the color, the intercotyledonary area. How does it look between one cotyledon and another cotyledon? Is it cloudy or not? Umbilical cord, is it covered for what? Any exudate, fibrin that you have, pus that you have. it's always important to remember that when you're sampling, you want to keep a track of the placentomes, meaning if you have the whole carcass with access to the placentomes, because that means that you have to have the uterus. How does it look with the umbilical cord? You want to temple all the portions of the placenta, the amnion, meaning the inside bag of the cow, the inside bag, and also the allantoids, which is the portion of the inside. And then it's either for fixed tissues or fresh tissues. You're going to have inflammation, and this could be seen as acute or chronic. And like any other organ, you're going to see fibrin in acute, fibrosis in chronic process. You can also have many type of exudates, suppurative exudate, or any modifier as necrotizing. The distribution can be focal or diffuse. When it's focal, is you better than examine the entire placenta, because that doesn't mean that you might be missing something if you only grab one part of the horn and the other part of the horn. All right, so we're going to jump into a section that goes between, is this a lesion or is this a finding? We have this structure here. So what is this? It's a meaty portion. So this is a placentum, a caruncle, with a caruncle, and they call it adventitial placentation. So it's the space between the one caruncle and another one. It's actually, so it's the cordium. It actually starts in the cordium, and it's actually an additional attachment to the endometrium, which is what we're looking at right now. It's common in ruminants specifically that you have additional placentum, but it's described in Job and Kennedy, the latest edition, that actually when you have intercotyledonary, meaning between the spaces, placentation and cattle, it's actually considered mechanism adequated. When you have that, means that the uterus needed more compensation of oxygen, for example. So it's an inadequate development of placentomes, more specifically. And I've had multiple, like one reference mentioned that they were not being reported in sheep or goats, but I thought, I haven't seen in sheep or goats. But then I found another reference that said that has been reported in other ruminant species. So I don't know which other ruminant species they defined by being also cows. So you have an idea that approximately you're going to have about 75 to 120 caruncles, more or less. And they actually develop more, like you're going to have more presentation dependent, not presentation of caruncles, but that's the number that you much more or less like have in mind. The other presentations or other pathologies that could indicate or require the formation of adventitial placentation, and we're going to see in a second. So when you see adventitial placentation or adventitious placentation, it means that there's an imbalance of the intercotyledonary placentation, and it's a compensation mechanism. All right, this is amniotic plaques. And amniotic plaques are this. They're localized on the fetal portion of it, and they're localized on the amnion. And they're plaques between 0.5 centimeters to, actually, I've seen like 5 centimeters, like really big, thick ones. And they look thicker. They sometimes look, oh, this is definitely something extra thick, and it's yellow. It's definitely fibrosis. It's definitely necrotic tissue or some fungal etiologies. They're normal. They're found in all species, in other species, but only the ruminants actually presented in the amnion portion. Sometimes because it's some type of keratinocyte structure, sometimes it's been reported that hair can grow too. So you have to just watch out how to look, or what does it mean microscopically. This is a normal finding. And like I mentioned before, sometimes you can actually see hair grow in these particular areas. So a few weeks ago, I ran into this cool case where this was a long gestation animal. It was a Jersey. This is a Jersey who was 50 days, 50 more of the gestation. And the measure from crown to rump, 96 centimeters long. And my apologies for the blurry picture because there was no way I was able to take the picture properly. But I wanted to show you this. So a huge, huge fetus, yellow, which is telling me that the animal was stressed. So that's meconium staining. And inside the wish cavity, the amniotic cavity, there were multiple herbals, free. And I don't know, I call it amniotic herbals. And there were about, this is the first round, but there were in total 30 something, 30, I think there were 32 herbals. And when I was discussing this with my colleagues, they were like, well, have you cut out the inside and see if that could be what is being reported, that a hair growth presentation of the amniotic plaques? It was just her. There was no center with epithelium inside of it. It's just her. So my theory is that the animal was so hairy because it was so big that it was moving inside the uterus, and then the movement and it causing shedding, because you can see how it's kind of like long hair on it. So be mindful of other things that could be a similar presentation. So normal structure, normal finding, I should say, that we could have a different presentation and that you want to see it. Is this what we're looking for? We have seen this picture before. We open everything, so you're exposing the fetuses. You don't have the amnion fluid out, so it's out, and then you can see the fall of the amniotic sac. So this is the amniotic plaques. So like I mentioned before, they're squamous epithelium, and they're mainly localized, or most commonly localized, in this portion of the umbilical cord. That's where you're going to see them first. But you can see them here too on the back, or you can see them like flakes too. You see, it looks like flake, but then when you move it, they're actually attached to the amnion. Like I said, they go between 0.5 centimeters. I've seen like 5 centimeters really big. And it's the internal portion. So just remember that it's amniotic plaques. That means that are going to be in the fetal portion of the membranes. And it's more commonly, or most commonly observed in the umbilical cord. And they could have this papillon form, like kind of like finger type projections. And they start appearing during the middle trimester, so the second trimester. And they can actually, so that's why people say that can occur in different species, but this discussion. These are not in ruminants, these are in horses, and this is what they call endometrial cups. And this is different because this is actually on the endometrium of the mare. But it happens because the trophoblast actually transplant and goes to the other side. And this is really interesting because this structure can actually produce the equine chorionic gonadotropin. So that's actually going to be one of the sources of this specific hormone that will maintain the pregnancy. And the tissue can become necrotic specific days of gestation. And then this is going to actually go to the fetal chorion portion to produce progesterone and maintain the pregnancy. But it's something, structures to keep in mind. Both latest editions of both books are describing it. And they can become necrotic. And when they're necrotic, they're going to have a lymphocytic response, like very severe, coming from the mom. So this could be inflammation associated to these particular structures, but that doesn't mean it's actually a lesion. There's another finding that is called, it's actually the position of amyloid in the caruncles, and it's been described in goats and two sets of population. One of them was in California and the other one was described in Michigan. These pictures are taken from VSBO from the Michigan case. So you're looking at the uterus, and the uterus, you can see someone's head and someone's ear, tiny ear. So this is a fetus, and you can tell that this is one and that this is another one. So it's actually macerated fetus. And you can see how the caruncles 1, 2, 3, all this are super, like they're thick, they're large. They're also pale. You can see in a smaller picture, pale or tan, or pale pink to tan. What do we know about amyloidosis? Is specifically that it's been, like I said, it was described in a small population of California, and it's just specifically to the caruncles. And when they were going through these cases, they identified that actually there was no other deposition of amyloid in the rest of the body. It was just localized here. So this could be, they also identify different breeds. I think it was La Mancha and Toggerbird. So there might be some predisposition for specific breeds for this specific condition. It's something to keep in mind as a differential diagnosis for causes of abortion that are not infectious. These cases, at least in California and this particular in Michigan, too, they performed specific testing, and all of them ended up negative for Brucella and for chlamydia and Coxiella. So no infectious pathogen detected simultaneously. And like I mentioned, the caruncles open here. You can see the surface house. They call it pale tan. I would call it a little bit more yellow, but it's glossy, right? So it's really thick and meaty, and it's like open and uniformly. And microscopically, this is a picture that I showed before. The labyrinth is completely effaced, and with a high magnification, you can see this picture is also taken from the same case. And a higher magnification, you can see how inflammatory cells scatter like eosinophilic with like, I don't know, like the specific amounts of cellular debris. But more significant is actually lust of Everything is eosinophilic. Everything is one color. And then when you do your specific stain, which is Congo red, and then you put the pearlizer, you can see actually the specific like green birefringence under the microscope and the pearlizer. All right, there's other conditions that imply a retention of fluids, which is the hydroamnios and hydroallantois. So there's two different ones. And in these two cases, or these two conditions, depends where the fluid is localized. But both of them are excessive accumulation of either the amniotic fluid or, as the name, allantoic fluid. So hydroamnios will be amniotic fluid, so it's the inner, go to my fake uterus, the inner smaller bag fluid, and the hydroallantois will be the allantoic fluid, the bigger bag fluid. Okay. It happens in cattle, and they're different. Like I mentioned, hydroamnios is actually also called hydrops, and it's associated to a malformation of the fetus. So it would be hydroamnios is in the amniotic fluid. I'm gonna repeat like a merolico in Spanish, like a singer. The hydroamnios would be the amniotic fluid, so the inner bag, the smaller bag, and it's mainly with a malformation of the fetus. It could be some specific. They said there's some predisposition with specific breeds. They also said hybrids of between cattle and bison, and muscle issue malformation type of thing. Yeah, like I mentioned, like mainly facial abnormalities. It kind of makes sense to be facial abnormalities because we talk about how the inner bag fluid, the amnion, is dependent on the saliva, or is composed of saliva of the fetus. So if there's an malformation in that sense, you might have accumulation of that. Hydroallantois, which is the bigger bag has to do with an issue with the uterus. So there's something happened at the level of the uterus that actually it's an inadequate number of caruncles, probably. So cotyledons and the caruncles of the uterus are not enough. So there's actually an imbalance and this issue with that adventitial formation and placentation. So that's why I mentioned in these particular cases, you're going to see adventitial placentation associated to hydroallantois. That doesn't mean that when you have adventitial placentation, you definitely have hydroallantois. But there's a correlation. People are like, oh, I have a lot of fluid in the bigger bag. I also see adventitial size of placentation in this particular organs. And this is usually presented with animals that are twins and has been also reported in embryos that have been cloned. The large amount that has been reported is about 170 liters, so it's a lot of fluid. So these animals comes huge distension of the uterus with a gigantic amount of fluid, allantoid fluid, which is the bigger bag. Another thing that people observe is that the membranes are a little thicker, so they're actually really hard to rupture sometimes. By other times, like this specific fetal membranes are really thin, and because they have to have an interchange between it. But this one is cloudy, thick, hard. This is a really interesting document from teams Brazil, which is a case of hydroallantois in 3 cows due to a specific poisoning of Sira carpinfophylla. In this particular case, there were 3 animals, and this is a picture from the reference, and you can see how gigantic the uterus is. Like this is to be the intestines pushing over there, and this is huge. You also see how, remember, where is it coming from, right? It's allantoid fluid. You should have still another bag wrapping the fetus by itself. And in this case, they also observe our friends, the adventitial placentation, you see? So it's not pathognomonic. However, when you have hydroallantois, you usually see adventitial placentation in these cases. All right, so we talk about placenta mineralization. There could be different types of mineral presentation. One is deposits, and the other one is what they call heterotopic ossification. I have never seen it, and it was kind of hard for me to find actually microscopic pictures, but it's heterotopic ossification is mentioned in John and Kennedy, and they mentioned to be many osteoclasts in specific placentas reported in goats and sows and pigs. So mineralization, we see it frequently, and it's mainly in the chorial allantoic membrane, so the outside part of it, like the chorion and the inside of it, the allantoid. And it also been reported that cases in ruminants with chlamydia or chlamydophila infection, they tend to have portions of mineralization. The mineralization happens in specific part of the gestation. Is usually more commonly described after the in ruminants, at the end of the second trimester. And this is another presentation. This is not mineralization, but I wanted to put it because it's really rare to just describe it, but I have not seen it, which is a necrotic cordialantois, which is the tips of the horns that will be necrotic, which is a finding. It doesn't mean that it's actually something going on wrong. These two pictures were taken for a really good paper done in South American camelids, alpacas and llamas, and they describe the mineralization of the fetal members in the placenta very well. You can see on the picture on the left and the picture on the right. The picture on the right is a von Casa, and you can see the distribution of the black. The blackness is the black portions is actually associated to areas of mineralization. And the surface of the epithelial portion will be here, so it has an epithelium. And then the specific picture on H&E, which is in nematoxin, you can see how the mineralization is actually it's more in the stroma is characterized by the heads like the brown dark portion of it. In this particular article, with Dr. Christine Loero and Schaffer were able to identify interesting lesions. So they took about 100-something cases of abortion in silvers, and they went through all these cases and see what's the most common lesion. And the most common lesion described was bullous hypoplasia, which I said common lesion because once it was characterized, it actually ended up improving the diagnosis. Cases that had undetermined etiology, then were able to put it and say like, oh, actually bullous hypoplasia. So bullous hypoplasia, it's this. You have like short branching of the specific chorionic villi. You see this portion is like really thin. This is a picture taken from a human placenta because humans do get this. This is actually really well described, and it's usually associated with poor branching, so there's actually not good reaching of the villi. And it means that there's failure to normal villi maturation, so that's gonna actually interfere with the maternal and fetal exchange. So horses do have this issue, and apparently also alpacas, and it's a true lesion, and they call it to be associated to what they call placenta insufficiency because they identified that actually it could be associated to abortion. And then on this table on the left, you can see the findings and how they interpret it from this particular paper. They went through bullous hypoplasia to poor bullous development, which is not the same, but they actually before diagnosing the hypoplasia, and they identified that also mineralization was present. It was mainly incidental because they were interpreted along with age and other lesions. It's a microscopic finding. You see how they call it a finding and not actually a lesion yet because they're trying to see what does it mean. And the lesion was mainly, like I said, in the apical portions of the villi. This is a cool, interesting conclusion. There's an other presentation for placentas, which is called the hydatidiform mole or placental mole. And this is drama here, or there's discussion here. Because, okay, Javin Kennedy mentioned how hydatidiform, the embryo, sometimes the embryo or the conceptus is swimming. So it's an embryo, so it's very young, like less than 30-something days, so swimming. And sometimes it actually dies and disappears, it's absorbed. However, the membranes persist and they keep growing like, oh, I do think I have a fetus or a conceptus. So that specific process or the cysts that are formed, they're called placental mole. But there's some discussion because some people call them interchangeably, they call them synonyms, but there's other people that do agree that hydatidiform mole is when the fetus is actually born alive and then dissociated or actually ended up being aborted. But it's accompanied by an alive animal. So in this particular case, the picture was taken from the specific site, from Florida team. But you can see how there are many cysts. And I don't even able to identify, maybe this will be the caruncle over here. No, maybe this is the cotyledon coming through it. It's really confusing. And then on the next picture, you can see, I like how they use what I think is a box of cigars. So as comparison. But you can see how many structures, it almost looks like fat. So, but this is supposed to be cystic structure. So cystic will have fluid. I think the distinction, or not the distinction, I think the discussion about when to call which one, when is hydative mole to placenta mole, could be if it's a retention of Cl, corpus luteum. So if it's a CL, then actually you do have an embryonic death or not, and then how it continues to go. All right. So more specifically for inflammation and the inflammatory response, we know that trophoblasts are cousins of the macrophages. So they do have some phagocytic capacity. We see it in how some pathogens are seen under the microscope. So some pathogens that you can see them inside the trophoblast. And you can see also production of exudate, fibrin, or proliferation of connective tissue fibrosis in any other organ. So that happens to the rest of the body. So the placentitis, the inflammation is going to happen when there's enough time for response. And that's important to remember because sometimes it's too quick, you have aversion and you have inflammation. So that could be more systemic, a fever, stuff like that. So chronic lesions, they're going to be obvious. You're going to see fibrosis and it's going to be like, oh, there's no doubt. Then something I find really interesting is the neutrophils can have a maternal origin. So they actually come in through the specific portion of the fetal veins, or the maternal with neutrophils actually come into the chorioamnion portion of it. And they actually can go to specific, the intervilli portion of the placenta, and it's going to be an acute chorioamnionitis, so acute inflammation of the fetal placenta, of the fetal membranes. But it's pretty much coming from the fetal and umbilical vessels. So keep that in mind. All right, so in ruminants, the chronic inflammation is going to be associated with, more specifically, one area between the cotyledon. And I'm going to show you what the intercotyledonaries are, or the pericotyledonary areas are. So you do have edema and fibrosis, and it kind of looks, fibrosis is going to be super, super significant and super characteristic, but they're going to both look cloudy in the portion. We also have what they call the cupping of the cotyledon, which is, the cotyledon will be eventually like this, but when it's cupped, when it's something extra, it goes like here. So it's going to be like a tiny cup. You can have exudate on the chorionic surface, which is the surface from the outside. And then you're also going to have cotyledonary necrosis. So any process that any part of the world you want to see it. Okay, so this is my marker for pause for water because I'm talking too fast. We almost getting there. All right, this picture, you've seen this. Look at this baby face. It's almost like scam. So we're looking at that portion of placenta. After all what we have been talking, what type of animal is this placenta belonging to? Ooh, people have to yell. No, they cannot yell because there's no connection for access to it. Maybe on the chat. I can give you hints. It
Don't
will
be
be
shy. You can
don't be
write one
shy.
chat.
You don't have to. I'm not looking at the names, so people can do it, and we don't even know the names. So there's two things I want to give hints. There's freckles over here, freckles, speckles throughout, and what I think, one portion here, cotyledon, one portion here, a cotyledon. What's most probably the species?
Cattle. Someone
Yes,
saying.
absolutely. A ruminant. I like to say, yeah, a ruminant could be one. Yep, absolutely. So now you have your tools to feel comfortable saying like, oh, I know that placenta. And by that, you would like to use specific normal anatomy structures as an anchor to give you a hint. All right, we keep going. So, Melissa, how does the fetus get infected? They're going to ask me. And I tried to start talking about this before, and it's about the pattern distribution. So, depending on how the distribution of deletions you're observing, where is it coming from? So, more specifically, if we're dealing with the placenta, like placentitis, and then you do have the contact with amniotic fluid, which is the fluid closer to the fetus, then it's going to have contact with the fetus on the skin, and then the fetus is also ingesting the fluid, so you're going to have lesions on the skin, and the digestive tract, and in the lung. What if it's coming from the placenta then to the umbilical vein? Then it's going to have a slightly different pattern. It's going to actually go umbilical vein to the liver, and then we'll have any system. There are other patterns, specifically in horses, that we need to discuss, but we can do another occasion, which would be ascending, like any other ascending infection, venereal, which is actually coming exactly what it's come from inseminations or mating, and hematogenic or hematogenous form. All right, because I want to repeat until people get tired of listening to it. That way we learn. The distribution is going to be two different styles or types. If it's actually coming from the amnion to the amniotic fluid, it's actually going through the lung because the fetus is going to inhale ingested. Ingested is going to be to the gastrointestinal tract. And sometimes you can also see in the eyelid because it has contact directly to the skin. So you can have a mild conjunctivitis or a conjunctivitis itself. If it's coming from the umbilical vein, then you're going to have all the affections, liver, lung, kidney, heart. You see how lung is in both of them? Because it's tricky. Lung can actually be communicated with everything, but just something to keep in mind. All right, you've seen this fetus before. This is another diagram that I asked AI to help me do it. And I'm okay with this. I'm not okay with the fact that they put placenta like it's a human placenta, but little battles. Okay, this distribution of the lesions are going to depend on the pathogen. And it's very important because if you understand this part, then you can actually don't need to memorize how does it look when it's a leptospira case. Because you do know what is it coming from. Or how does it look when it's a brucella case. So 3 columns. One is going to be if the fetus is going to die really quick. So it's going to be acute fetal infection. Another one is going to be if the fetus actually slowly dies, which something that will be more a chronic placental infection. And then the third one is kind of tricky because it's actually mediated by prostaglandins, and it's kind of convoluted, but just bear with me. Oh, I just noticed another thing. It has a human uterus. All right. Take this, but really careful because again, it was generated by AI, but the purpose is to categorize different groups of different characteristics, and that way we can learn. So if we're dealing with acute infection, it's going to be a bacterial, a virus, but mainly infections that can cause septicemia or sepsis or a systemic disease, which is that will actually cause a sudden death of the fetus, and then before actually the abortion is even happening. So it would be a specific bacteria or a specific viral entity. So the fetus is going to die quick, actually before the expulsion. So it takes time and is therefore going to be autolyzed. Then you're also going to have autolysis, but the degree of autolysis is kind of complicated. So severely autolyzed fetuses, you can think about something that actually killed the fetus really, really, really fast before actually was actually rejected or aborted. On the second group, it's going to be something more like like a chronic placentitis. So it's a slow death situation. And that's when the mycotic abortions come, or brucella abortus, which is a placentitis. Originally, the main way to cause harm is through the placentitis. And then the fetus is actually going to be preserved a little bit longer. So it's going to be evaluation. So the fetus is going to be well preserved. You're not going to have that many chronic issues or like lesions associated to it. And the third one, they call it prostaglandin median abortion, but it's pretty much very characteristic of ureaplasma. Ureaplasma diversion happens to be very specific type of lesions. And this specific one, sometimes the fetus is actually mildly autolyzed, but it's usually most of the times fully well preserved. So it's going to be mildly autolyzed, not too bad. The main issue or the main key thing for ureaplasma is actually going to happen because it goes with a cytokine storm, macrophages activation, and then premature expulsion. There's some obsession in this role. Sometimes bovine herpes virus does not cause crazy autolysis. So sometimes you just see the fetus like super quick, is super fresh. Just keep in mind that depending on the damage to the placenta, how the fetus is going to be exposed. All right, so we have a beautiful picture of a cod litter. This is your cod litter well demarcated. And what I call the intercotyledonary area, which is this portion to here, because I have another cod litter here. That area, I was told one time that you should be able to grab it and put it on top of the newspaper, and you should be able to read through the newspaper because how clear it is. When you're not able to see the clearness between the intercotyledonary area, that means that there's something extra, and that means there's inflammation or fluid. So edema or inflammation, or edema and placentitis. There's also going to be a degree of hemorrhage in any delivery because being born is a stressful process and it's actually an inflammatory response to. But too much is too much, and too little is too little, so it's kind of hard to draw the line, I would consider this hemorrhage or this blood clot significant. You also have what we call before the cupping of the cotyledon, which is when the cotyledon has something extra. It makes a cup size because it's actually full of stuff, has more cells, has fluid, edema. So this is actually a placentitis, and it's a placentitis due Coxiella burnetii, which is Q fever, a reportable disease. Is this actually a species in cattle? At the beginning, people associate Q fever mainly with small ruminants, but you can have Q fever in bovines, and Q fever can be released in normal delivery, or can be shed in normal delivery. So you have to keep in mind when you're using your specific PPE equipment. Microscopically speaking, like I said, it's a placentitis, and you have these trophoblasts, which are the cells around the cotyledon portion. So you have this. You have also necrotic debris, neutrophils in area expanding, and you see these arrows, not arrowheads, but the arrows. There's something like extra inside those cells. This is a placentitis necrotizing, but if you go to high magnification, we can see how the cytoplasm of these trophoblasts here and here and here are occupied by this amphiphilic, sometimes basophilic, purple basophilic material, and those are bacteria and that are inside the cytoplasm or trophoblast, which few bacteria do that. But in this particular case, it will be Coxiella burnetii. If you do testing or ancillary testing like immunohistochemistry, you can see how it's very localized on the cotyledon and is very localized to the cytoplasm of the trophoblast. So that's significant. All right. So you also have another pathogen that can cause placentitis, which is Campylobacter. And depending on the species, you do have two different species. You got fetus, and Campylobacter jejuni. And that will be sporadic abortions in cows, but abortions like waves or storms in small ruminants. More specifically, Campylobacter fetus subspecies venerealis is actually a venereal transmission, like the name says. So it's important for some producers to distinguish the subspecies because they want to know where it's coming from. And that's why the identification of the bacteria is important. Sometimes the pattern is, so there's some references that say that with Campylobacter, you see mainly in the cotyledon, and you see mainly in like the other species like Chlamydia intercotyledon. So it can change. So I will try not to marry to that story. This is a particular picture from Dr. Anderson that you can see one cotyledon, two cotyledons, and then the intercotyledonary area, and has all these plaques. That is not adventitial plus placentation. That is actually inflammation. That is not nearly plaques because, well, it's next to the cotyledon. It's not on the specific membrane, but it's actually inflammation and necrosis. And you can see how the center of the cotyledon is also facet, so it's necrotic. So you have necrosis of the cotyledon and necrosis of the intercotyledonary area. You also have fibrin, so that will be fibrinous placentitis, and you can see how everything is facet. Some people call it pepperoni cotyledons. Some people don't like to use food terms. Another associated finding in the fetus, not in the placenta, will be fibrin covering the heart and fibrin covering the pleura. So fibrinous pleuritis and fibrinous pericarditis. There's also reports of multinucleated giant cells or multinucleated cells in the lung for cases of Campylobacter. I've seen it really rarely, so there's something to keep in mind. This is Campylobacter venerealis in aborted fetus. All right, so this is in English. The English speakers have this expression that goes, this is the hill that I'm going to die, which represents like when you are stubborn, that go about something a lot, like really, really, really a lot. And this is my hill because I got burned by this twice and I want to be home when like this happens. All right, so we're looking at a section of placenta, and this is cause of abortion in a small ruminant. This is actually an article, but I've seen this case before twice. So trophoblast on top, you see the nucleus of trophoblast, and then you have these round structures. So all this stippling, all this basophilics or purple stippling is not on the trophoblast and underneath the trophoblast, and this is very key. The picture on the right is a picture of the Coxiella burnetii or coccidiosis case of when we can see inside the trophoblast. You see this is a cell, this is a cell, this is a cell. This circle represents what we call the subtrophoblastic sinusoidal capillaries. Subtrophoblastic sinusoidal capillaries. So the bacteria are localized in different portions in these two sections. The section on the left is actually in the subtrophoblastic sinusoidal capillaries, and the bacteria on the right is actually in the trophoblast. If you're on a rush on a Friday afternoon and then you're looking at your slides and then you say like, oh, basophilic stippling. Oh, this is definitely, one of them is reportable and one of them is not. Both of them can be zoonotic, but well, Celebinitis is strong zoonotic. And the lethal dose of Coxiella is very, very little. So you don't want to be the pathologist who misses a diagnosis. So like I said, this is the hill that I'm going to die. The pattern, this is why important to identify patterns. Where the lesion or where the bacteria is localized is going to give you a hint. This case particularly is subtrophoblastic sinusoidal capillaries. This is actually empty or has red blood cells, so the bacteria is actually in the trophoblast. So there will be two different distributions. There are other bacteria that can be in the trophoblast besides Q fever, and that will be chlamydia. Chlamydia is also reportable. Chlamydia is important too. But keep in mind is the distribution will be more necrotizing and also going to have inflammation of the vessels, vasculitis. The diagnosis can be done with immunohistochemistry. And there are some other species of chlamydia, Chlamydia pecorum, in fetuses that can actually cause different presentation like fibrinous pericarditis or fibrinous peritonitis. And also accumulates of the bacteria and vessels in the heart and the vessels in the brain, and also areas of gliosis or inflammation of the brain in the aborted fetus. This flying fetus is actually a fetus that was aborted by herpes. Remember I said that herpes usually could be, the fetus would be so idolized? Well, sometimes it's not like that because biology does what it can. And it's mainly presented in cases when an outbreak and it's associated with poor vaccination history. So sometimes you don't have any gross lesions commonly. So something to keep in mind. And macroscopically, why we're here is because you do have necrosis placentitis, necrotizing placentitis, and mainly lymphoplasmacytic. But yeah, this is a picture taken from the Bible Kirkbright's diagnosis abortion. In this particular fetus, we had a fetus in the placenta, and you can see how the cotyledons one here, cotyledons, they're doing the cupping, right? They're like doing like ventosas, like cups. And you can see how it's almost like close, like so thick that it's almost like touching to each other. And then once we keep going to the right of the picture, the portion of the placenta looks like leather, looks like dry, and it's everywhere. So this is classic mycotic abortion, in this particular case by Aspergillus fumigatus. The diagnosis can be done, well, special stains and also cultures. There are cases when you do have what we call a sporadic abortion, and it's opportunistic bacteria, which would be bacteria that are commonly, that can be pathogenic, but they're not described, their pathogenesis as abortion, like Q fever. It's just because it's a sepsis, it's a bacteremia, and it's enough to actually cause an inflammation in the placenta. So you see, for example, the intercotyledonary area, one portion here, and it's thicker, it's thick in it, and it's actually red too. So it's thicker, so it has something extra. It has a change in color, so it's red, and also has fibrin associated to it. So this is bacterial placentitis. I forgot to put the gene. This is another image because I'm so stubborn. I keep putting images from my references and notes and see that, hey, help me understand this by different colors and grouping things. All right. So the lesions in ruminants associated specific by the macroscopic lesions, the microscopic, the gross, the histo, and then what the pathogens associated to this pattern, and then key features. Again, AI keeps pulling my placenta like it's a human placenta. One day. All right. So we do have different patterns. For example, if it's suppurative, you can have necrotizing, you can have mycotic, which is tricky because here we use some modifiers, suppurative and necrotizing, and here we use an etiology, mycotic. So stay with me. Also, another key lesion in placenta with vasculitis, and that will give you specific lesions like hemorrhages, and then edema, because it's a damage of the vessel, so the compromise of the blood supply is actually there. And then you do have bacteria that cause vasculitis, like Chlamydophila, Campylobacter, and Brucella. So you also have the interstitial placentitis, which could be more generalized, and that's commonly seen in lepto, which is spirochetes. If it's necrotizing placentitis, it's seen commonly in protozoa. It's Toxoplasma gondii. It says sarcocystic, but we all know what it means, Neospora. And then suppurative placentitis, which means like pus, right? Like neutrophils, infiltration, necrosis of the trophoblasts. That could be also caused by the ones that cause vasculitis, which is Brucella, and chlamydia and other bacteria. So just group in terms, for example, how does it look? So when it's necrosis, dead tissue, dark, brown. So it's going to be brown, depressed, because it's necrotic, like sunk in. When it's suppurative, pus is going to be, or fibrin, it's going to be pus in the cotyledon. It's going to be yellow, white, green, and it's actually be thickened because it's more of the cotyledon, and also have edema. When it's mycotic, well, mycotic is tricky because there's also vascular damage in the fungal placentitis. So there's going to be an infarction, so you're going to have a really well demarcation of healthy and unhealthy color. So you can also have dark brown, and then gray, so it's different colors. And they talk about interstitial placentitis, how you have hemorrhages. Placentitis, it's kind of hard to see placentitis in leptospira, but you do see it, and without too much necrosis. So the purpose of this slide is to kind of start thinking of what does it mean when you have a specific modifier and a specific pattern of necrosis and a specific pattern of lesions like vasculitis and hemorrhages. All right, so we're getting close, and I just want to bring up this beautiful article, 2019. Oh man. If you're starting to see what is placenta and what are the normal findings of placenta, go to this document, because Dr. Bota did a great job describing like what does it mean is too much. And pretty much the logistics of the conclusions is that you're going to see cellular debris in any degree of cellular debris associated to the cotyledons. And people say like, oh, it's necrosis. But when they went in immunohistochemistries and identified that it's actually mainly apoptosis, which makes sense because the placenta, it's swimming out. It's closing the tap at the table and say like, cerrame la cuenta, because they're leaving the body and they need to become apoptotic. So that's why you will have more reaction or apoptosis. But at the same time, you also want to have cellular debris associated to that. And we know that necrosis and apoptosis calls for inflammation, some degree of inflammation. And the apoptosis marker that they use, they notice that increases during the terms of late gestation, which also makes sense. And absolutely during the postpartum period. So apoptosis, mainly not necrosis, and it's not the same. They also identify that there's inflammation, there's myoflammation, and it also includes either vasculitis, which we just talked about how vasculitis can be caused by pathogens. And then there's also going to be mineralization, which are normal findings. You see what we talk about, normal histologic findings in the bovine placentas. And the diagnosis of the detection of placentitis, the detection of the specific pathogens by DNA, by PCR. So if you say Q fever, Coxiella burnetii detected, hold your horses. I know it's a zoonotic, I know it's a very low infectious dose, but you always have to associate lesion with the pathogen. So if you have a PCR positive for this pathogen and you don't have lesions, you might want to take caution. It is important to report it. Yes, it's important to say it is there. But what does it mean in terms of the diagnosis? So the diagnosis of placentitis should always base in everything. The lesion pattern, where it's affected. If it's only necrosis of the horns, well, it's actually a process that occurs, that it happens in the process of the horns. Is it distribution, how severe it is, and then collaborate with ancillary results, meaning doing PCR, meaning doing bacteriology. If you have an E. coli isolated and really small numbers and no lesions associated, what does it mean? So for conclusions, I wanted to leave this room and say, well, you know what? Melissa said that not every lesion is going to be a disease. And I mean, because apoptosis that you're going to see with your microscope in the eye is not the same as necrosis, because it implies specific physiologic process. When you have a PCR that is positive for any pathogen, you do want to be careful and say, what does that mean for the causation? When you have inflammation that is mild, that not necessarily means that it's placentitis. Melissa, when is mild, when is moderate? You're gonna get it with experience, but at the same time, you're gonna get it with the confirmation of how big is affected, what portion of the placenta is affected. So it's gonna be pattern distribution, ancillary test. In terms of the context, for example, you always have to interpret the lesions in the specific context, and this is going to be the context. The distribution of your lesion, how severe your lesion it is, the gestational age. Does it make sense to be this apoptotic if it's just about to be released? Yep, because you have more degree of apoptosis. What lesions are associated in the fetus when you have fetus and placenta? Do you have lesions in the fetus or not? Sometimes you're not gonna have any lesions in the fetus and you're gonna have an insane placentitis. So always together. And also associated with the ancillary test, meaning what are your PCR saying, what is your bacteriology saying, what is your immunohistochemistry saying. And with that, I want to say thank you to my team. My team is the California Animal Health and Food Safety, CAFS, located at UC Davis. We're located in different branches, Davis, San Bernardino, Tulare here. But I want to say thank you to them because it's really cool to work with them and so learn from them. And then Dr. Mark Anderson, Dr. Carolina Silveira, who was my PhD mate / friend. And most of the information that I have been developing for a couple of years was with her and Dr. Robert Muller too, because all the interesting cases are also discussed together. This is my email. So please feel free to email for any questions, gossips, or complaints. This next one is actually the reference, but they're not all the references. Just a little bit of thought. I thought it was interesting. And with that, I think that'll be it. Woohoo! Time for questions. I'm gonna stop sharing. Wait, I'm gonna close this.
Hi, Emily. Thank you so much for the presentation. I've learned a lot. So, and we don't have questions, just one comment that actually you already answered it. Someone was asking for your email for questions or comments. Maybe it's up to you. And remember that to all, we'll be uploading this to YouTube. So, if you want, if it's possible to share the presentation with these guys. So ask her with email, please. I have a question here. IHC positivity will mean the same for the diagnosis as PCR positive?
No. Well, yes and no. Nothing is straightforward. So when we're doing PCR or ISH, we are detecting the genetic material. And when we're doing immunohistochemistry, we're detecting the antibody-antigen reaction. So there are some things that might change this. For example, if the sample was affected by autolysis, that might interfere with the detection of genetic material. If the sample has been placed in formaldehyde for a long time, that might interfere with the detection of the antibody-antigen reaction. So you do want to take a conscious and smart decision in terms of the distribution of your immunohistochemistry and the lesions, because the cool thing about immunohistochemistry is that you can, and also ISH, is that can you see the immune reaction, the color reaction in the tissue associated to a lesion. So if you have a foci of necrosis in the trophoblast, like what we have with Q fever, I'm gonna arrow all the way back. We can actually say like, oh yeah, it's actually associated to my areas of necrosis and inflammation. Unlike with PCR, you can say like it's there, and it could be really low numbers, or it could be a really low numbers or high or large numbers. Depending on type of PCR too.
Okay. Other questions? We're struggling here to find primary antibodies against Coxiella or Toxoplasma. That's one comment. Do you recommend endometrial biopsy in cattle before gestation?
Oh, that's a good one. We don't do endometrial biopsy for cattle. Endometrial biopsy will be more for horses because how horses are in terms of like a lot of money in terms in also cattle, but a lot of money in terms of it. I have colleagues / friends that are clinicians in dairy cows, and they don't do that. But I know the same group of people were doing endometrial biopsies for the cases of amyloidosis in small ruminants. So I'm not that familiarized with that one, but I would expect that it's more common in horses.
I don't know about this, but I suppose that probably it will be more interesting to have a biopsy of an actual caruncle rather than the rest of the uterus, right? I suppose.
That's actually a good point too, because what does it mean if it's a positive and what information that it's giving you?
Okay, thank you so much. Thank you so much. Any other questions? I have one quick question regarding the amyloid deposition in some abortions. You mentioned that happened in the endometrium, right?
It is in the caruncle.
In the caruncle. Okay, so if there is an associated lesion in the chorioallantoides, for instance, or in the
I don't
fetus?
remember. I don't remember. I believe it's not in the fetus, but I would think it would be mainly the labyrinth of the caruncle. Yeah.
Okay. Thank you. So, any other question? And if not, you have Melissa's email there. And remember, this will be uploaded to YouTube in the future. So, we don't have two more questions. We can call it a day.
It was fun. Thank you.
Okay, thank you so much again, Melissa. It was amazing. Okay, see you. Bye.
Bye.